Hey guys, welcome to the course on Network Mastery for Ethical Hackers. In this course, I will cover topics that are frequently asked in interviews, especially during the networking related questions. So if you have basic understanding of computers, you can join this course. Throughout these sessions, you will gain a comprehensive understanding of how networks operate. After all, having knowledge of how something works is crucial for ethical hacking. In this video, I will show you how to set up the Kali machine and Metasploitable 2 machine on VMware. So first search on Kali Linux download on Google and click on this Get Kali. Alright, and then click on Virtual Machine and then download it for VMware. Okay, click here. So it will start downloading this Kali machine for VMware. And on another tab, just search for Metasploitable to download and click on this Metasploitable. Okay, and you can download this Metasploitable from here. So after downloading this Kali Linux and Metasploitable, let's see how we can set up the Kali machine and Metasploitable to on VMware. Then you have to extract these files, this Kali Linux file and the Metasploitable Linux file. Okay, after extracting it, just open this VMware and then we will click on this Open Virtual Machine. And then click on this folder. After that, just click on this. So then click on this Play Virtual Machine. And then press N key. Okay, it will automatically start. And for Kali Linux, the default credential is Kali and Kali. Username is Kali and the password is also Kali. Alright, so we'll type the username and password. Okay, so this is how you can set up the Kali Linux on VMware. Now we'll see how you can set up the Metasploitable 2 machine. Once again, click on Open a Virtual Machine, then select the file. So the file name is this is a folder and here is a file. Okay, and just click on Play Virtual Machine. So starting up. So for this Metasploitable 2 machine, the username and password are msfadmin. Just type msfadmin for username and msfadmin for the password. So this is how you can set up the Kali Linux and Metasploitable 2 on VMware. That's all for this video. Hey everyone, in this lecture you will learn basics of networking. Before understanding networking, let's grasp the concept of a network. Hopefully you are aware of social network, where one person communicates with another. In the digital world, when one computer communicates with another, it forms a network, and this process is networking. So a network is formed when two or more computers exchange information over wired and wireless connection. Now, a network can be a small or it can be large, and based on that, we have some key terms in networking. First, we have LAN, which stands for Local Area Network. A local area network is a network of connected computers and devices within limited geographic areas such as home, office, or campus. Okay, in simple terms, it's a network that allows computers and devices in close proximity to communicate with each other, share resources like files and printers, and access the internet. Then we have a wide area network. A wide area network or WAN is a network that covers a larger geographic area than local area network, such as cities, countries, or even continents. The last we have is metropolitan area network or MAN is a type of network that covers a larger geographic area than a local area network, but it is smaller than wide area network. So it typically spans a city or a large campus and designed to connect various local networks. Okay, so in these three, the local area network is smaller in size, whereas the wide area network is larger in size. All right. Now, why network? Just imagine there is one computer in Russia, and this computer wanna share files with another computer in India. In this case, we need a network because without a network, these two computers cannot communicate with each other. This is why a network is important. By using a network, we can share files, we can share resources and programs, right? What are the key elements of a network? In a network, we have network interface card, network cables, hub, switch, router, and wireless networks like Bluetooth and Wi-Fi. Let's explore each of them one by one. Guys, this is network interface card. Here you can see the port where you can connect cables like Ethernet cables. So this NIC connects devices enabling communication, internet access and resource sharing. It is essential for wired or wireless connections. Next we have is network cables like an Ethernet cable. So now what's the role of this Ethernet cable? The role of an Ethernet cable is to provide us with internet connectivity. Next we have is hub. A hub is a basic networking device that connects multiple computers, allowing communication and information sharing. However, it is a dumb device lacking data filtering or intelligence. In this diagram, you can see all the devices are connected to the hub. So if data is received on one port, it's rebroadcast to every connected device. So that's a drawback, right? Like if two devices share a file, the data is broadcast to the entire network. The other devices will also receive the file. Now that you understand the issue with hubs, let's talk about switches. Unlike hubs, switches store MAC addresses, directing data intelligently. So in a switch, data is directed to the intended destination port when it receives a data packet. So it is intelligent device that stores MAC addresses. However, it is crucial to remember that hubs and switches are meant for exchanging data within a local network and not for data exchange outside the network, like the internet. So for routing data beyond the network, we need IP addresses. So these hubs and switches do not read IP addresses, and that's where the router comes in. So what is a router? The router routes data from one network to another based on IP addresses and it stores both IP addresses and MAC addresses. Alright. Next we have wireless network. So guys, hope you know what is a wireless network, like Wi-Fi, Bluetooth, these all are wireless network. Okay, next we have network topology. In simple terms, network topology refers to how devices are connected in a computer network. So there are different types of network topologies like bus, star, ring, and mesh. Let's explore each one. So first we have is bus topology. In this, we can see there is single communication line shared by devices like all the cars on one road, and a device can talk on this line. So then we have a star topology. In this star topology, you can see there is a central hub. So devices connect to a central hub. And then we have is ring topology. The devices form a closed loop, each connected to exactly two others, and it is creating a circular pathway for data. Okay, and then last we have is mesh topology. So in mesh topology, every device connects to every other device, providing multiple paths for data. Guys, one thing note here, Starlink that uses mesh topology. Okay, that's all for this lecture. Thanks for watching. In this lecture, you will learn about the goals of network security. The primary goal is to protect data from unauthorized access. So in simple terms, it's like building a strong fence around your house for safety. So how can we achieve it, right? So what are the ways to achieve it? First, we have confidentiality. That is like locking doors, keep your secrets safe, ensuring only the right people can access them. Next is integrity. That is like guarding things against changes, ensure data remains unchanged by unauthorized individual during transmission or storage. Then we have availability. It is like keeping the lights on, ensure services and resources are always available when needed. And then we have as authentication. Authentication is like checking ID cards, verify the identity of people or devices trying to connect to the network. Okay, and then next we have is authorization. Authorization is like permission slips, control who can access what on the network based on their permission. And then the term is encryption. So encryption is like locking things up, protect information by turning it into a secret code that only the right people can unlock it. Okay, then we have is accountability and auditing. So it's like keeping an eye on things, keep tracks of who comes and goes and what they do for security checks. Okay, and lastly we have incident response and recovery. So it is like having emergency plans. We're always ready to respond quickly if something bad happens and have a plan to recover and fix things. That's all for this lecture. We'll see you in the next lecture. Thanks for watching. Hey guys, in this lecture you will learn about network protocols. Network protocols are like languages that computers use to communicate with each other over a network. Just as people need a common language to understand each other, computers need protocols to exchange information effectively. So there are numerous protocols in computer networking, but in this lecture, the focus will be on TCP and the UDP protocol. Okay, now let's talk about the TCP protocol. The TCP is Transmission Control Protocol. In short, reliable data transmission by dividing information into packets, verifying delivery, and managing errors. It is connection-oriented protocol that guarantees packet delivery through a three-way handshake, as explained in the next video. Now let's discuss about UDP. UDP is User Datagram Protocol. Unlike TCP, UDP is connectionless, lacking a handshake. So delivery to the destination isn't guaranteed in the UDP protocol. So when to use TCP and UDP, right? For crucial messages requiring guaranteed delivery, like emails, use TCP. And for scenarios where requested data loss is acceptable, like YouTube streaming, use UDP. So TCP supports unicast, while UDP works for unicast, multicast, and broadcast. So that concludes this lecture. Thanks for watching. Guys, in this lecture, you will learn about the three-way handshake. The three-way handshake is a process used in computer networking to establish a reliable connection between two devices, typically within the context of transmission control protocol. So as mentioned in the previous lecture, the three-way handshake is employed in TCP, right? It ensures that both devices agree to establish a connection before data is exchanged. So in a similar manner, if two individuals want to communicate, both parties need to agree before they can engage in a conversation, right? So guys, here we have client and the server. So the client is sending a SYN packet to the server. Now what is a client? Client is your browser and the server where all the data is stored. Okay, so here you can see the client is sending a SYN packet. That's a synchronization packet to the server. Now what's the meaning of the SYN packet? It's like, yeah, I want to talk to you. Okay, so the client is sending a message to the server that I want to talk to you. And the server will respond with SYN and ACK. Okay, server will respond, so I got your message, let's talk. And then again, the client will send third packet, that is acknowledgement packet. I got it, let's start talking. So here acknowledgement meaning that I received your message. Once this three-way handshake is complete, the devices can reliably communicate with each other. If at any point during the handshake there is an issue, the connection is not established and the process may be retried. Okay. So let's see how it works using Wireshark. Okay, just start the Wireshark. So if you don't know what is Wireshark, Wireshark is a network protocol and you can use it to observe the communication between a client and the server. Okay, so I'm opening it. After opening the Wireshark, choose the interface. I'm choosing this ytshorts. And here it's gonna start capturing the packets. Okay, then what I'm gonna do, I will visit a site. Let me visit www.google.com. So I just type the domain name and now you can see it has retrieved the google.com, right? Now let's check what Wireshark has captured. I'm stopping the Wireshark here. So guys can see here, you can see the TCP protocol that is being used in this. Okay, first it is sending a SYN packet. Let's find that SYN packet. So here you can apply the filter. Just type here TCP. That's gonna show you all the all the packets that are related to TCP. So here you guys can see this is a source and this is the destination. Source is your browser. So this is your browser IP address and the destination here is google.com. Okay, so the client is sending a SYN packet to the google.com and the google.com is sending, and the server is sending SYN and ACK, SYN plus ACK, and then again the client is sending a acknowledgement packet to the server. Okay, and then the connection is established. Now they can talk to each other. Okay, so this is how it works. Okay, and you can capture the packets using Wireshark. So that's all for this video. Hope you have learned something. In this lecture, you will learn about the OSI model. OSI model is Open System Interconnection Model, and it is a reference model for understanding network protocols and communication. Okay, so the OSI model, it is having total 7 layers. The first layer we have is, if we start from the bottom up, first layer we have is physical layer, then data link layer, then network, and then transport, and then we have session, and then presentation, and the last we have the application layer. So it is from the bottom to up. But if we follow top to bottom, then we have first layer we have is application layer, and the last layer we have is physical layer. Okay, so what is a physical layer? This is hardware layer. Think of it as cables, connectors, and devices that physically connect your gadgets. It's all about getting those electrical signals or radio waves from one place to another. Next we have is data link layer, that's layer 2. Now imagine this as postal service of the digital world. It takes care of addressing and packaging data into neat parcels called frame. It also makes sure the data gets to the right place. Okay, next we have is network layer, that's layer 3. This layer is like the GPS of the internet. It figures out the best route for your data to travel across different networks, and it uses logical address, that's IP address, to guide the way. Okay, and then we have transport layer. So this is a layer that ensures your data arrives in the right order. It manages the flow of information, checks for error, and resends anything that got lost. Then we have a session layer, layer 5. Imagine this as conversation manager. It maintains and closes conversation between application on different devices. It ensures smooth communication. And then we have presentation layer, layer 6. This layer is like the translator. It takes care of converting data into format that both sender and receiver can understand. It deals with encryption, compression, and other format related tasks. Finally, we have as application layer, layer 7. Here is where your apps live. This layer enables communication between software applications. It's where your browser, email, or games interact with the network. Guys, in this diagram, you can see one is sender and one is receiver. So if sender want to send a message to a person, so what layer it's going to use in the OSI model? So it follow the top to bottom approach. Whereas in the receiver side, it's going to follow the bottom to approach. Okay. So think you want to send a message or you want to send a mail to a person. So for mail writing, you will be using the application layer, right? And the presentation layer will be sending the data in a way that receiver will understand. Okay. All the encryption, decryption will occur in the presentation layer. And then we have this session layer. Session layer is going to start the session. Okay. Like you are sending a mail. So this session layer will start the session. Then we have a transport layer. So it decides whether TCP or UDP is used in this. So in mail sending, if you're sending a mail to other person, so that's going to use the TCP protocol. Okay. And then we have a network layer. So network layer, in the network layer, it's going to add the IP address of the destination and IP address of the source. Okay. Then we have a data link layer. So data link layer, it's in this layer, it's going to add the MAC address. And the last we have is physical layer. So data is sent out of the network using the Ethernet, right? So when the data reaches the destination, the other side, how the receiver will receive it, right? From the bottom to up, from the physical layer, then data link layer, right? So receiving side will process the data in the same way, but in the reverse order. So if you are sending a message from an app to the device, so that's going to follow from layer 7 to the layer 1. So that's going to follow the layer 7 to layer 1. Okay. That's all for this lecture. Thanks for watching. Guys, in this lecture, you will learn about IP addresses. So what is an IP address? Think of it as digital postal code for your device on the internet. Just like how your home has an address, your computer, your smartphone, or any device connected to the internet has a unique set of numbers that make up its IP address. So every device on TCP/IP network must have a unique IP address. Okay, and most of the device they use IPv4. IPv4 stands for Internet Protocol version 4. Now the 4 in IPv4 is important because it signifies that we are dealing with 32-bit address. Now what is a 32-bit address? Well, it is like having 4 billion unique addresses on the internet. Just like your home has a unique address, every device connecting to the internet, whether it is your phone, computer, or smart fridge, gets its own unique IP address. It's IPv4. So how you can calculate it, right? If you want to calculate number of addresses in IPv4, then there's a formula 2 raised to power n, where n is number of bits. So in IPv4, n is equal to 32, and 2 raised to power 32 is around 4.3 billion, right? So let's break down this 32 bits into simpler terms. It looks like 192.168.1.1. So here you can see each segment separated by a dot and is representing 8 bits. So guys, 1 byte is equal to 8 bits. So in total, you have 32 bits making up your unique address. Guys, do you have any idea how many devices are there in the world? Well, there are more than 9 billion devices globally. But here is a catch. IPv4, the Internet Protocol version 4, only provides around 4.3 billion unique addresses. That means we are facing a shortage of IPv4 addresses. So that's where IPv6 comes into play. IPv6 uses a 128 bits address, and where you crunch the numbers, it's incredibly massive address space. Now, what's the difference in IPv4 and IPv6? So IPv4, it was deployed in 1981, whereas this IPv6, it was deployed in 1998. Okay, and IPv4 is 32-bit, whereas the IPv6 is 128-bit. Okay, in IPv4, you can calculate number of addresses. It's around 4.3, and it is a large number. You can see 7.9 into 10 raised to 28 addresses. Okay. So in this, addresses must be reused and masked, and every device can have a unique address. Okay, because a large number, so every device can have a unique address. In this, it is all decimal, right? And in this, it is hexadecimal. Okay, and how you get this IPv4? Either through DSCP or through manual configuration, and it supports auto configuration. Okay, that's the difference in IPv4 and IPv6. Now we'll see the classes of IP address. First, we have Class A IP address. In Class A IP address, the maximum number of hosts is 16 million. So how it is 16 million? So as you know, the formula for calculating number of addresses is 2 raised to power n. Okay. So here you can see number of hosts is, okay, here number of hosts, how you can calculate is 2 raised to power 24. How it is 24? Because in network, here you can see the network, we have assigned 1 byte for network. In Class A IP address, the network will get 1 byte, whereas the host will get 3 byte. Okay, so 1 byte is equal to 8 bits and 3 bytes is equal to 24 bits, right? So that's how you can calculate it. 2 raised to power 24, it's 16 million. It's around 16 million. Then next we have B class, but where we are using this A class A IP addresses. So it is designed for larger network. As you can see, there are lots of IP addresses, right? Lots number of hosts are 16 million, right? Then we have this class B IP addresses. So in class B IP addresses, maximum number of hosts is 64k. Here 2 byte is assigned for the network and 2 byte is assigned for the host. So hope you know 2 byte is equal to 16 bits. Okay, 16 bits is for the network, whereas 16 bits is for the host. So if you want to calculate number of hosts, that's 2 raised to power 16. Okay, and next we have is class C. So class C, maximum number of hosts is 254, and for network 3 bytes is for network and 1 byte is for host. Then we have class D. Class D we are using for multicasting, whereas the class E we are using for testing. Okay, then next we have is private IP addresses range. So guys, these all are private IP addresses range. So these private IP addresses, it works only in the internal network, like local area network. Okay, and what's the use of this private IP addresses? So it helps in conserving public IP addresses space, and it adds an extra layer of security to the internal network. So guys, let's see how we can check the IP address. Now guys, let's see how we can check the IP address in the Linux operating system. I'm using Kali Linux. So if you want to check your IP address, just type ifconfig. That's going to show you the IP address. Okay, so for ETHO, it is displaying me 192.168.174.153. So this is my IP address. Okay, this is a local IP address. And here you can see the netmask and the broadcast address. We'll see what is a netmask and what is broadcast in a separate video. And here we have is IPv6 address, and this is the MAC address. Okay, now if you want to change your IP address, then how you can do that? Just type ifconfig and then the ether, then the interface name, and then just type any IP address. Okay, so I want my new IP address as this one, 10.0.0.1. So let's hit enter and let's check our IP address has changed or not. So you can see our IP address has changed. So in this way you can change your IP address. Okay, that's all for this lecture. Thanks for watching. Hello everyone, in this lecture you will learn about subnetting. So subnetting is a technique used in computer networking to divide an IP address into smaller, more manageable parts called subnets. So what is a subnet? Subnet is a network within a network. Okay, so subnetting is like dividing a larger piece of land into smaller plots, and it helps manage and organize IP addresses efficiently. Okay, so we can create subnets within class A, class B, and class C network. Hope you know what is class A, class B, class C network. So to do this, we use something called subnet mask, which helps determine the network and host portion of an IP address. So if I ask you what is the network portion here and what is the host portion here in this IP address. So here if you see the subnet mask 255.255.255, this is the network portion and the 0 is the host part. Okay. Guys, this 255.255.255.0, this is subnet mask. And in CIDR notation, you can denote it like this, /24. What is CIDR? So CIDR is classless inter-domain routing notation, and it is a way of representing an IP address and network mask that is associated with it. Okay, so /24, that means 24 bits is for the network, whereas 8 bits is for the host. Okay, if 8 bits is for the host, then how we can calculate number of addresses? So using the formula 2 raised to power n, right? 2 raised to power 8. So in this case, there will be 256 hosts, okay, for this subnet mask. And if you want to denote this subnet mask, then you can denote as like this, /16. /16 means 16 bits is for the network and 16 bits is for the host. And then next we have /8. /8 means we have 8 bits is for the network, okay, and the remaining 24 bits is for the host. So if 24 bits is for the host, then how we can calculate number of addresses? As 2 raised to power 24. So here we have the subnet mask. This is the subnet mask. This is for class A subnet mask, and this is for class B, and this is for class C. So you can see 255.0.0.0, that is for, this is for the host and this is for the network. Okay, and if here also we have 255, 255, and then 0 and then 0. So this two parts is for the network and these two parts are for the host. Then next we have is subnet masks table. So here you can see 255. So in binary, if we want to denote this 255, we can denote in like this: 1 1, all 1, right? So here 1 means part of the network and 0 means part of the host. Now what I mean by that? So here you guys can see this mask. We can represent in binary like this. And number of bits are 8 and how many subnets will be there. So if you want to calculate number of subnets, you can use the formula 2 raised to power n. So in this case, it is 2 raised to power 8. So 2 raised to power 8 is 256, right? And maximum host in this case is 0. Okay. So in this case, in 255, if the mask is 255, then the maximum host will be 0. And if the mask is 0, then there will be maximum number of hosts. If there are more binary ones in the subnet mask, it means that more bits are reserved for the network portion, resulting in larger subnets. So let's use a tool for understanding subnetting, the subnet calculator. This tool can determine subnet ranges, broadcast addresses, and the number of hosts in a subnet. Here you have to enter the IP address and then just click on this calculate. Before that, first we'll choose the network class. Here I'm choosing any, okay, and then let's take the subnet, okay. So I'm choosing 255, 255, 255, and 0/24. So hope you know what is /24. /24 means this three parts is for the network and this one part is for the host. And there will be 256 hosts, okay. So let's click on calculate. So here you guys can see the result. This is our IP address that we entered, and this is the network address, and these all are the usable host IP addresses from 1.1 to 1.254, and this one is a broadcast address, okay. And there will be total number of hosts as 256 and number of usable hosts as 254, whereas this is subnet mask, this is wildcard mask, and in binary subnet, in binary format you can write in this way, okay. The subnet mask can write in this way, all ones and these all 0. And this is class C IP address, and in CIDR notation you can denote like /24. This is a private IP address, okay. So in this way you can calculate subnet ranges, broadcast addresses, and the number of hosts. Let's delve deeper into subnetting using Nmap. Nmap is a network mapping tool. First, let's check our IP address. Our IP address is 192.168.174.153, and this is the net mask. So here you can see net mask is 255, 255, 255, and then 0. So this is for the network and this is for the host. So we got our network part. So let's write Nmap. This is the network part. Okay, we'll start from the 0 and /24. /24, hope you know what is /24. In a /24 subnet, the subnet mask has 8 bits for the host, okay, and 24 bits for the network. And let's hit enter. So there are 2 raised to power 8 total addresses, which equals 256. However, we exclude the network address and the broadcast address, okay. So the network address here is, this one is a network address and this one is the broadcast address. We have excluded these two addresses here. So here you can see it has scanned the entire network from 192.168.174.1 to last 0.5254. In this, there are total 254 usable addresses per host. Therefore, running this command will scan for the total 256 hosts. But keep in mind that 192.168.174.0, that is the network address, and this one is the broadcast address. And we are effectively scanning the usable host within the range 192.168.12254. Okay, that's all for this video. Thanks for watching. Hey guys, in this lecture you will learn about what is a MAC address. So MAC stands for Media Access Control, and a MAC address is a unique identifier assigned to a network interface on a device. It is like fingerprint for your device network connection, and these MAC addresses are usually expressed as series of hexadecimal numbers separated by colons or dashes. Colons in Linux operating system, whereas dashes in Windows operating system. So for example, you can see this is this MAC address 001A. Okay, this is in the format of hexadecimal, right? So this is colon 1 and this is the dashes. And no two devices on a network can have the same MAC address. Okay. So what's the key difference in MAC address and IP address? So an IP address locates a device across networks, while a MAC address identifies the device. So guys, let's see how we can check our MAC address in Windows operating system and as well as in Linux operating system. In Windows operating system, you use the command get MAC. That's gonna display your current MAC addresses. Okay. So here you can see here it is displaying me these many MAC addresses. Okay, it is all for the network interface cards. And here you can see if I want to check in Linux operating system, I just can type fconfig and that's gonna display me the MAC address of the Linux operating system. So that's all for this lecture. Thanks for watching. Guys, imagine if every time you joined a Wi-Fi network and you had to manually configure your device. Annoying, right? So DSCP eliminates that hassle. DSCP is Dynamic Host Configuration Protocol. It automatically assigns IP addresses to every host on the network. And now how this DSCP assigns IP addresses. So first your device connect to a network. It asks, can I get an IP address? And then the DSCP server responds, sure, here's an IP address and some network details. Okay, then now your device has a IP address for the network communication. Okay, so DSCP is like an automatic system that hands out unique address to devices, and there is no manual configuration is needed. It happens every time when you connect to a network. Okay, so but if you want to request a new IP address from the DSCP server in Linux, you can use this command sudo tsclient and the interface name. Now the interface can be ytho or wlan 0. So guys, here you can see in wlan interface I do not have any IP address, right? So let's request a new IP address from the DSCP server. If you want to request IP address, just type dhclient and the interface name. Okay, this command will request a new IP address from the DSCP server. Okay, just type sudo dhclient and the interface name. So here we can see we got the IP address for this interface. That's all for this lecture. Thanks for watching. Guys, in this lecture, you will learn about DNS. So DNS, or the domain name system, functions as an internet phone book. It resolves domain names to IP addresses. As we are aware, memorizing IP address can be challenging, but remembering domain names is more convenient, right? So DNS serves as the internet phone book. Rather than memorizing numerical IP addresses, we use human-friendly domain names such as google.com, right? So DNS translates these domain names into corresponding IP addresses. So that enables us to access websites and other online services. So let's see how it works. Guys, when you type google.com into your browser and press enter, your computer sends a request to the DNS server asking for the IP address associated with google.com. So the DNS server then looks up the IP address for google.com and respond to your computer with the corresponding IP address. Let's say it's 74.125.142.147. Okay. So then your computer can connect to the server at this IP address. And that's gonna retrieve the web content and display the google.com website in your browser. So in these steps, the DNS system enables your computer to translate the human readable domain names into the necessary IP addresses. Okay. So guys, this is DNS lookup and this is the reverse lookup when you ask the Google, when you ask the DNS server who is this IP address, and this is gonna respond with the domain name. Okay, that's reverse DNS lookup. In DNS lookup, you are just typing the domain name into your browser and getting the response from the DNS server. Whereas in reverse DNS lookup, you are typing the IP address and getting this domain name as a response from the DNS server. Then next we have is DNS poisoning. Okay, now just imagine here we have an attacker, and an attacker is injecting some fake DNS entry into this DNS server. So when the client will request a website, imagine the client is requesting google.com. Okay, so if this attacker has manipulated this DNS entries, okay, then it will redirect to a fake website. It will not redirect to a google.com. It will redirect the user to the fake website. So let's see it practically how this DNS poisoning works. Let's execute the DNS poisoning attack. I'm conducting it on my local machine and it is limited to the local environment. The initial step involves manipulating the entries in the host file. So simply type leafpad and /etc and /host. So we're going to manipulate this file. Okay. So here you can type your local machine IP address. Okay. And here I'm writing google.com. Okay. So I have changed the entries in this host file. And then what I'm going to do, I'll save this file. Hope this is visible. Okay. And then I will start the Apache 2. Then what you can do, you can start service Apache 2 start. That will start the Apache 2 service. And if you type here google.com, okay, this is gonna open the Apache 2 page. Okay. And even if you type your IP address here, this is gonna open the same page. So here you guys can see this is redirecting me to this page, this Apache 2 page. That's how it works. That's all for this lecture. Thanks for watching. In this lecture, you will learn about SNMP. SNMP stands for Simple Network Management Protocol, which enables network administrator to monitor and manage various network devices such as routers, switches, printers, and more. So it operates at the application layer. The command SNMP check -t IP address. Okay, here is IP address 192.168.1.1 is utilized for SNMP enumeration. So this tool will display information related to SNMP, version information, community string information, and system information. It might also attempt to enumerate user accounts or assess control information associated with SNMP. I hope you found this tool useful. That's all. In this lecture, you will learn what is ARP. ARP is Address Resolution Protocol. It resolves IP addresses to the MAC address. So here we have a command ARP-A that's going to display you the current ARP cache on your computer. So this cache, it contains mapping of IP addresses to the corresponding MAC addresses. So guys, whenever a device wants to communicate with another device on local area network, it needs a MAC address. Okay, so let's see how this ARP works. Imagine this scenario with device A and device B. So think this is device A and this is device B. When computer A wants to communicate with computer B, computer A already knows the IP address of computer B. However, to establish communication, it still needs the MAC address. Consequently, computer A sends out a broadcast message inquiring about the device with a specific IP address. And this computer B will respond with the MAC address. Okay, and once this computer A obtains the MAC address of this computer B, the communication will start. Subsequently, the information will be stored in ARP cache. So to check that information in Windows operating system, you can use ARP-A command. So guys, here you can see we use ARP-A. That's going to display us the IP address and it is mapping to the MAC address. And it is even showing the type. One is dynamic and one is static. Okay. Static entries are those entries which you can enter manually. So if you want to enter it manually, just type ARP, then -s, then the IP address, and then the MAC address you can type, and then you can just hit enter. So that's gonna enter the static entry. Let's understand ARP using Wireshark. First execute this command netdiscover-r and this IP address /24. So that's gonna scan your entire network. Okay. So just hit enter and then start your Wireshark. Okay, I'm choosing the ytshorts interface. Let me start it again. And then now observe that ARP is in use. And the Wireshark that displays the devices holding specific addresses by sending ARP request. Once it identifies the device with the targeted IP address, it showcases the mapping of IP address to the MAC address. Okay, like in this case, we can see we got this IP address with the MAC address. Okay, so it is asking who is having this IP, and then again it is asking who is having this IP, right? So here you can see this MAC address is having this IP address. So that concludes the content for this video. That's all. In this lecture, you will learn what is Wi-Fi. So Wi-Fi, short for wireless fidelity, is a technology that allows devices to connect to a local area network without the need for physical cables. It's like magic that brings the internet to your smartphones, laptops, and other wireless enabled gadgets. So how it works? So Wi-Fi, it uses radio frequency signals to transmit data between devices and Wi-Fi router. So these signals, they operate on specific frequency bands, commonly 2.4 GHz and 5 GHz. okay, to ensure efficient communication. So when you connect your device to a Wi-Fi network, you are essentially establishing a wireless link with the router. So in this we have some key terms. The first we have is AP. AP is access point. So the client connect to the Wi-Fi and get internet access. That is access point. Then we have WLAN. WLAN is wireless local area network. And then we have BSSID. BSSID means the MAC address of this AP. And the next term we have is SSID. SSID means the name of the AP. Like free Wi-Fi is the SSID because it's the name of the Wi-Fi network. Whereas the device or hardware that enables the wireless connection is the access point. Okay, so how many channels are there in that? We have total 14 channels. Okay, next let's talk about the wireless encryption. So in this we have WEP, WPA, then WPA2 and WPA3. First we have is WEP, wired equivalent privacy. WEP was one of the earliest encryption methods for securing Wi-Fi networks. It is like very basic lock on your Wi-Fi door, but over time it has been proven to easily breakable. So it is not recommended for secure networks. Next we have is WPA. WPA is Wi-Fi protected access. So it was introduced to address the vulnerabilities of WEP. Think of upgrading from a basic lock to one with a stronger mechanism. So it provides better security than WEP but has some limitations. And then we have is WPA2. It is Wi-Fi protected access 2 and it is more secure than WPA. Okay, as we have upgraded it again, and this time to a more advanced lock with better protection. So it became a standard for secure Wi-Fi connection for many years. And then next we have is WPA3. WPA3 is Wi-Fi protected access 3. And this is the latest standard introduced to further enhance Wi-Fi security. And this one is more secure than WPA and WPA2. But why we are not using this WPA3? So because of the compatibility issues, some older devices they do not support WPA3. That's why we are not using this WPA3. Okay. In wireless networking, devices such as wireless network interface cards can operate in different modes to perform specific function. So first we have is master mode that is used by access points or routers to create a wireless network. Then we have is managed mode. So it is used by clients devices to connect to a wireless network that is created by access points in master mode. And then we have is monitor mode. It is used for passive monitoring and packet analysis without actively participating in network communications. So guys, hackers they operate in monitor mode. Guys, for performing these commands practically, you need a wireless adapter. I'm using the Panda wireless adapter. Now let's explore some networking commands related to Wi-Fi. So these commands can be useful for managing and troubleshooting Wi-Fi connection. So the first command we have is iwconfig. So this command will display you the information about wireless interfaces, including their names, connection status, and the signal strength. So here you can see for this WLAN 0 interface, the mode is managed and it is displaying the frequency. Frequency is 2.4 gigahertz. Okay. So let's see how we can convert this managed mode to monitor mode. Use this command ifconfig WLAN down. So this will put the interface down. Next command we have is iwconfig WLAN then mode monitor. So this will set the interface to the monitor mode. Okay, and then type ifconfig WLAN 0 and then up. Okay, so this will bring the interface and then use the command iwconfig and let's check our interface is in monitor mode or not. So here you can see the interface is in monitor mode. Okay, now guys, this interface is in monitor mode, so let's run a command arrow dump ng and then WLAN 0. So this is used to capture and display information about nearby wireless networks. So when you run this command, this tool will start capturing and displaying information about nearby Wi-Fi networks. So like the BSSID, the power, the beacons, okay, the encryption and the SSID. Okay, so that's gonna display you all this information. So if you want to exit from here, just press Ctrl C. So guys, if I want to capture the data on a specific channels, then I can specify this option -C and then 1, 6, and 11, that's gonna start capturing the data from these channels. Okay, so if I hit enter, what it's displaying me, aerodump ng hyphen c 1 comma 6 comma 11, then the interface. Okay, let's type it again. Will not give any space here. Here you can see it has start capturing data from networks on these channels. So that's all for this video. Thanks for watching.